Hi guys, my name is Peter C. Dogwa Jr., your math tutor and instructor of mathematics at the University of Liberia. And in my today's lecture, I will be discussing differential equation. Under differential equation, I will be looking at additional problems involving eliminating arbitrary constants to obtain the differential equation. So this is question number 7. We have x minus c1 cos of omega t minus c2 sine of omega t. Now, x is the name of the function and t is the variable of it of the it is the kind of independent variable within the problem. So whenever we differentiate x, we must attach x prime. Additionally, to eliminate arbitrary constants within, let's say, to obtain the differential equation, what we need to do is first we need to identify how many arbitrary constants do we have. So the number of arbitrary constants determines the number of times we have to differentiate. So since we have two arbitrary constants, it means we must differentiate twice. So we do the first one. This is just derivative of x is just 1. But since x is the name of the function, we attach x prime. Minus, so this is just one term, so it's c1. Now the derivative of cos is negative sine of omega t times the derivative of the angle is just like saying 2t. So this equal to 2. So likewise with this just equals omega. Then we have minus c2, the derivative of sine is cos of omega t times the derivative of. So when you differentiate the trigonometric function, they say if you have y equals to sine of x, sine of ax, y prime now will be sine of ax times the derivative of ax. So this is exactly what we're doing. So sine of omega t now is equals to cos of omega t times the derivative of omega t, which is just equals to omega, or equals to 0. So that's the first derivative, but let's simplify first. Negative and negative is positive. So this now becomes c1 omega sine of omega t. And then this is now minus c2 omega cos of omega t, or equals to 0. So we have differentiated for the first time. We find the second derivative, which is now x prime prime plus c1 omega times sine of this. So we differentiate this one. We have cos of omega t times the derivative of omega t is just omega minus c2 omega. So cos of this one is negative sine of omega t times the derivative of omega t, which is just omega, or equals to 0. So we have x prime prime plus, so this is now c1 omega square cos of omega t minus c2. So negative and negative is positive, c2 omega square again. And then you have sine of omega t equals to 0. Now, our concern here is to solve for c1 and c2. Now, what do you observe? In the previous problems we were doing, when we differentiate the first time, at times one of the variables or the arbitrary constants would disappear. And when we differentiate for the second time, sometimes it disappears totally. But for this case, it's just it's just appearing, in a kind of circular form, especially when we are dealing with the trigonometric function. So we have to apply some tricks to be able to get rid of C1 and C2, because we are already seeing the differential equation. We're seeing some x prime prime, but we cannot have C1 and C2. So let's go ahead. Let's further do this one. Now, what do we know? We know that something actually was repeating. We differentiated cos from the beginning. We got sine. Later, we came back to cos, and we are now at cos. So it's like going back to the original problem. So what if we factor out, now we have w square or omega square, omega square. What if we factor out omega square? What will be left here? You got C1 cos of omega t plus C2 sine of omega t equals to 0. Now compare it with this one. If we now say C1 cos of omega t, C1 cos of omega t, C2 sine of omega t, C2 sine of omega t, but we got negative here. So what if we factor out the negative, right? Or for short, what if we say, let's send this term across. So if we send this term across, it becomes C1 cos of omega t. We send this term across, it becomes positive C2 sine of omega t. So what do you observe? You observe that we have gotten a single variable for these two terms. So anywhere we see this expression, we're going to write x. So this is our differential equation. So it can be rewritten as dx. Now remember, we have the variable t for this problem, right? So we can have dx or the 2x all over dt square plus omega square x equals to 0. So it can be written in this form, or if we decide to multiply this entire expression by dt square, that is the 2x divided by dt square plus omega square x equals to 0. If we multiply this whole thing by dt square, we will have the 2x plus omega square x dt square equals to 0. So many ways we can form it. But the major thing is that we have arrived at our differential equation given this functional relation, or given quote unquote the solution to this differential equation. So thanks ever so much for watching. Please don't forget to subscribe to my channel, and also don't forget to subscribe, to hit the share button, hit also the alarm button, so that at least you get more updates whenever we upload. Thanks ever so much. See you in our next video.